Okay, next we are moving to the Thevenin theorem. Okay, in this Thevenin theorem, look at here. In this particular circuit, it shows about everything about the Thevenin theorem. So here, this is a circuit we have. In this circuit, different resistances R1, R2 and R3 and V1 is present. So in this Thevenin's theorem, according to the statement of Thevenin's theorem, the Thevenin's voltage calculated is here. The Thevenin's voltage E is a open circuit voltage at the terminals A and B. So whenever you are calculating the voltage source across the open circuit terminals, that means they mention the load resistance that may be open circuited. So just calculate the voltage across this open circuit is nothing but a Thevenin's voltage. So here Thevenin voltage is nothing but a open circuit voltage at open circuit terminals. Okay, next, what about Thevenin's resistance? That is a RTH. So Thevenin's resistance means, see here, the Thevenin's resistance R is the resistance seen at AB terminals. That means you can see in from here, right? Seen all voltage sources replaced by short circuited. For example, voltage source is present, that should be short circuited and replaced by the short circuited, and all current sources are replaced by open circuited. These points are very important. Voltage sources are short circuited, current sources are open circuited. So then you are finding out in the Thevenin's resistance. So once you got both, the combination here, Thevenin's resistance as well as Thevenin's voltage. So in this particular diagram it shows clearly, this is a network we have. This is a network. Across these open circuited terminals they mention, maybe that may be connected to the any load resistances. So this particular circuit you are converting to Thevenin's resistance in series with Thevenin's voltage. These two terminals as it is kept open. This is about the Thevenin's equivalent circuit. Thevenin equivalent circuit. Right. So here, in the examination, they will ask the question like, in case of Thevenin's theorem, which statement is correct? And below 4 options are provided. Voltage in series with resistance, or next current in series with resistance, current in parallel with resistance, voltage parallel with resistance. So these are the different combinations. This is the statement is correct. That means you are thoroughly understand the concept behind the Thevenin's theorem. We can answer any question. Okay. So Thevenin's theorem is nothing but a resistance between open circuit terminals keep all sources deactivated. That means in case of voltage source is short circuited, current source is open circuited. Okay, let me take the example to make you understand Thevenin's theorem clearly. See here, this is a circuit. I want to calculate the voltage across current flowing through the load resistance 15 volts. Okay, this is the problem. You need to calculate the load current IL. So how to calculate the load current? Step by step I am going to explain. So here, step 1. What is the step 1? Find RTH. That is the step 1. So how to find RTH? Just now I explained. Voltage sources are present or should be short circuited. If internal resistance is present, replaced by the internal resistance. In place of short circuit of voltage, in case of ideal voltage, internal resistance is not present. It should be short circuited. In case of ideal current source is present, internal resistance always infinity, ideal case. Okay. So internal resistance in case of current source, everyone remember, in case of current source, internal resistance of ideal current source is infinity. Internal resistance of ideal voltage source is 0. But it is not a ideal voltage source, internal resistance mentioned in the problem, that's why 1 ohm is replaced by 24. Fine. Remaining 3 ohms and 12 ohms as it is, keep as it is, and then AB terminals are kept open. Now I seen from AB terminals, this is the RTH. So now 3 ohm and 1 ohm, here 3 ohm plus 1 ohm connected in series, right? That may be equivalent to 4 ohms. Let me take that is a R equivalent 1. So finally RTH, Thevenin's resistance, is equal to that 4 ohms parallel with 12. So 4 into 12 divided by 4 plus 12. That may be equivalent to 4 into 12 divided by 16. 1 time, 4 time, 1 time, 3 time. That may be equivalent to 3 ohms. Clear? So everyone clear about the Thevenin's resistance, how to find out the Thevenin's resistance. Next, step 2. In the step 2, Thevenin's voltage VTH. So how to find out the Thevenin's voltage? Just now I explained in the previous, just 2 minutes back, this particular video. Voltage source, everything as it is, just open circuit these two terminals. Voltage across this open circuit is nothing but a Thevenin's voltage. Okay, that means Thevenin's voltage or open circuit voltage, both are same. So how to do that? See here, this 24 ohms, internal resistance is 1 ohm. This particular circuit is a series circuit because there is no current flowing here, 0 amperes. So 3 ohm and 12 ohm are connected in series. We can apply voltage division rule. So in the voltage division rule, 24 is the total voltage into, you want to find out the 12 ohm, same resistance, 12 ohm divided by total resistance of the circuit. The internal resistance of 24 ohms is 1 plus 3 plus 12. That will be equivalent to 24 into 12 divided by, this is a 16, right? 4 4s are 3 4s are, okay, 1 6 4s are 18 volt. So finally, you know what is the VTH? You got 18 volt. Once VTH you got 18 volt, step 3, to find out the load current, right? To find out the load current, say look at the circuit. VTH, this is a 18 volt. RTH, this is the RTH, Thevenin's voltage 3 ohm, as well as load resistance. Just you kept disconnected the 15 ohms, right? Now you are connected this 15 ohms in between A and B. Now load resistance IL is equal to, the formula is VTH divided by RTH plus RL. Okay, now finally VTH is equal to 18 divided by, okay, 3 RTH plus 15. That will be equivalent to 18 divided by 18. That will be equivalent to 1 ampere. So what is the load resistance now? 1 ampere. This is about the Thevenin's theorem. For your understanding purpose, I explain step by step. In the examination, within 1 minute you can do the solution. In our mobile app, we are providing the test series also. Once you make you understand the concept, you can attempt the test series. Your final examination, that is a CBT examination for KVS students, Kendriya Vidyalaya work experience, those are attending. The examination is a CBT examination, computer based test only. So that's why your mobile app also computer based test. It will be very useful for you to attempt those tests. Okay, thank you. Next example 4.3. So here, apply Thevenin's theorem to find current flowing through 12 ohm resistance. Okay, this is a 12 ohm resistor shown in the figure. So I want to find out the current flowing through the 12 ohm. They are asking about using Thevenin's theorem. In the objective exam, we are preparing for KVS, that is objective exam. They won't mention any theorem directly find out the current flowing through the 12 ohm resistance. If it is mentioned, no problem. What way you are find out in the current flowing through the 12 ohm resistance, that may be same as Thevenin's. If you are applying the Thevenin's theorem, you will get the same current. Okay, but Now we will see, we are learning about the concept of Thevenin's theorem, right? I'm going to apply that. The first thing, to find out current flowing through the 12 ohm resistance, step 1 is RTH. Okay, that is a Thevenin's resistance. How to find out the RTH? Very simple. Just short circuited 36 ohms resistance voltage source, and this is a 6 ohm, this is a 4 ohm, and open circuit the load terminal, that is a A and B terminals. This is a A, this is a B. So just find out the total resistance. 3 and 6 are connected in parallel, that is equal to 6 into 3 by 6 plus 3 plus in series with 4 ohms. So finally RTH is equal to 18 by 9, that is a 2 plus 4, 6 ohms. Okay, clear? Next, step 2. What is the step 2? VTH, right? So to find out the VTH, just again to find out the VTH, draw the circuit diagram with presence of voltage source. That may be 36 volt, here 3 ohms, here also 6 ohm, 4 ohm. These terminals are open circuited still. Just find out voltage across the open circuit is nothing but a Thevenin voltage. So how to find out here? Just look at, this is the open circuit. Whenever this is open circuit, what about the current here? 0 amperes. Whenever current is 0 amperes, this is a dummy resistance. There is no use of that resistance. That means voltage across these two terminals is nothing but a Thevenin's voltage. That may be Thevenin's voltage VTH is equal to, how to find out? See here, these two are connected in now series. Can directly apply the voltage division rule, that is a total voltage into, you want to find out the 6 ohm voltage across 6 ohm resistance, that is a 6 divided by total 6, 3 plus 6, that is equal to 9, 4, that may be equivalent to 24 volt. So you got Thevenin's voltage is also 24. They are asking about current. So that is a step 3. Step 3 is load current. So you know Thevenin's voltage is 24. Thevenin's resistance is, how much resistance you got? Thevenin's resistance, just look at here, 6 ohms. And load resistance, they are asking about the load resistance current, that is a 12 A and B terminals. This is a 12 ohms. These are the A and VTH. The formula here, VTH by RTH plus RL. Okay, that is the current flowing through the load resistance. So that is equal to 24 divided by 6 plus 12, that will be equivalent to 1.33 amperes. This is the final result. Okay. Next example 4.4. Using Thevenin's theorem, calculate the current through 4 kilo ohm resistance. This is the current. This is a branch, you need to find out the current using Thevenin's theorem. So here 12 voltage source, 10 ampere current source is present. First of all, I am going to find out the step in the step 1 RTH. Okay. So to find out the RTH, current source, voltage source short circuited, current source open circuited. 3K, 6K, kilo ohm. Here you want to find out the voltage current flowing through the 4K, right? That should be open circuited. You can see in from here, that is the RTH. Here 2K, this is open circuited. Now Look at here, this 3k, this 2k connected in parallel. So R equivalent is equal to 3k into 6k divided by 3k plus 6k. That may be equivalent to 18k squared divided by 9k. That is equal to 2 kilo ohm. Okay, you got, this is a 2 kilo ohm. Both are, sorry. Okay, you got 2 kilo ohm. Next, once you got that is a 2 kilo ohm, coming to here, this is a 2 kilo ohm. So our equivalents, for your understanding purpose, I am going to draw the circuit. 2 kilo ohm. This is the A. These are the B. Here 2 kilo ohm. Look at here. These two are series or parallel. These two are connected in series. Therefore, RTH is equal to 2k plus 2k. That may be equivalent to 4 kilo ohms. So what is the RTH you got? 4 kilo ohms is the RTH value. Then we are going to find out the remaining. Okay, next I am going to find out the voltage difference between these A and B terminals, that is nothing but a VTH. So VTH is equal to VA minus VB. Right. I am going to find out VA first. How to find out VA? You know, this is a 12 volt. You want VA, that means voltage across 6 ohm resistance, 6 kilo ohm resistance. Just apply the voltage division rule, that is a 12 into, you want this voltage 6 divided by 3 plus 6, 6k divided by 3k plus 6k. Is it okay? Minus, coming to here, this is the current flowing, this 10 amperes is flowing this 2 kilo ohm resistance, that is equal to 2k into 10 milliamperes. Okay, this 10 milliamperes, milli and this k get cancelled. So here 8 minus 20. So here B potential is higher potential compared to this. So we got 12 volt. We can take it as a B is highest potential, right? We can take VB minus VA also. Okay, VB minus VA, that is equal to 12 volt, because potential B is highest potential compared to VA. So finally our circuit will be Thevenin's voltage 12 volt and Thevenin resistance 4 ohms as well as load resistance is 4 ohms. You want to find out the current IL. IL is equal to VTH, that is a 12 divided by 4 plus RTH plus RL. 12 divided by 8, that will be equivalent to 1.5 amperes. Is it okay? So this is about the solution.